Okay, so now we are going for the last topic, piezo crystals. Okay, so what are these piezoelectric crystals? Okay, these crystals are available in the market. They are naturally made, they are natural crystals, and artificial crystals are also there. So some of the names of crystals are Rochelli salt, quartz crystal, barium titanate. All these comes under all these are different types of piezoelectric crystals which are available in the market. Okay, so depending upon our application, we can choose any type of the crystal. Okay, so what actually a crystal is? Okay, what will happen inside the crystal? Okay, so normally if you are taking a crystal, it is neutral. It is neutral means the crystal will be having charges, positive charges and negative charges. Before the application of any type of input on the crystal, okay, before the application of any type of input on the crystal, the charges inside the crystal are neutral. Okay, the charges in a crystal are neutral, like this. Okay, so what do you say is, this is my vertical axis, this is my horizontal axis. So normally a horizontal axis is also known as electric axis, and your vertical axis is also known as mechanical axis. This is known as mechanical axis. So before the application of any type of input, it will be having a charge plus minus plus minus minus plus minus. It is equally distributed, means it is neutral in condition. Okay, the same point I have explained here. Now the first point, suppose here we have to apply, so I can say that my piezoelectric crystal is, so first we will see one thing. First point is, suppose whenever you are taking a piezo, if you are applying an input, what type of output you may get. Okay, suppose on the vertical axis we can apply pressure. If you apply pressure, we will be getting output as voltage. Why? Suppose if you are taking this piezoelectric crystal, whenever you are going to apply a mechanical force along the vertical axis, then the charges gets distributed. The charges will try to move. Okay, so whenever the charges move, then one side of the crystal becomes more positive, and another side of the crystal becomes more negative, which creates a potential difference and gives voltage. Okay, same thing I am writing here. When force is applied on vertical axis, then one side of crystal is positive and another side is negative, and creates potential difference, and creates potential difference. Is it clear? So this is the first important point we are having. So the second one, you take a piezo crystal and you apply some input, and what is the output? Now let us assume you apply input as voltage. Okay, so obviously the output is nothing but vibrations. Vibration, we call it as ultrasound, or sometimes we can also call it as force also, not an issue. Okay, so how it is happening? So see here, so whenever we are going to apply voltage on the horizontal axis, whenever we are going to apply voltage on the horizontal axis, then the crystal is, depending upon the applied voltage, the crystal is going to compress or it is going to be expand. compress or expand. Anything can happen. So whenever this is going to happen, obviously the crystal starts vibrating. So vibrating means it will be emitting an ultrasound, or we can call it as a mechanical force also. Okay? When the force is applied, when a voltage is applied on horizontal axis, the crystal will expand or compress by producing vibrations. So in this case, the piezoelectric crystal is converting electrical voltage to non-electrical voltage. Hence, it is called as an inverse transducer. Hence, it is inverse transducer. Okay. One more important thing. Please listen here carefully. So for the piezoelectric crystal, always we should apply only. For a piezoelectric crystal, always we should apply only a dynamic input. Okay, we should not apply a static input. If we apply a static input, what will happen? What will happen means the output voltage, whatever the output you are going to get, the output will decay after some time, and it gives always 0 volts. Okay, this is mainly due to the input impedance of your piezoelectric crystal. This is mainly due to the input impedance of your piezoelectric crystal and op amp. Okay, op amp means signal conditioning circuit. This is very, very important point. Okay, if a static input is applied, then it gives 0 output. Why? This is due to input impedance of what? Signal conditioning circuit and the impedance of your crystal. Due to the impedance of signal conditioning circuit and the impedance of crystal. Hence, because of this reason, always we should apply only a dynamic input for the crystal. Hence, we should apply only dynamic input. Normally on this topic, on this concept, many times they ask a question. Okay, suppose if you are going to apply a pressure of 1000 Newton per meter square, but the pressure is static, what is the output of the crystal? The output is 0. Make this point clear. Okay. So these are some of the basics which are very important related to your crystal. If you are done, just reply, then I will go for the continuation part. Yeah, fine. So these are some of the important points. So if you are observing this case, so for the piezoelectric crystal, it doesn't require any external power supply. Hence, we can call the piezoelectric crystal as an active transducer. Our piezoelectric crystal is an active transducer. It is an active transducer. Okay. And one more important thing is that your piezoelectric crystal is exactly similar to your capacitor. How? The capacitor also will be having charge. This is also having the charge. The capacitor is having both positive and negative charges. Similarly, here also your piezoelectric crystal also having both positive and negative charges, but they are neutral condition. So it is exactly similar to your capacitor. Okay. Now please listen here carefully. Piezo is similar to capacitor. Okay, suppose this is your piezo. Okay, so this is nothing but the thickness, where T is thickness. So let it be T1, thickness of crystal before the application of force. Now what you should do, so this is the first point. Now what you should do is that apply some force. So whenever you are going to apply some force, it gets compressed. It gets compressed. Okay, so whenever it gets compressed, now its thickness is going to be changed. Now its thickness becomes T2. So T2 is thickness of crystal after the force. Okay, so this is known as delta T, which is T1 minus T2. So therefore I can say my F is directly proportional to delta T. My F is proportional to delta T. Okay, so here I can say this T, thickness is nothing but, it is, thickness is in piezoelectric crystal, it is nothing but distance between the two plates in a capacitor. Okay, thickness in crystal is equal to distance between the plates in a capacitor. Distance between the plates in a capacitor. Okay, now example of the piezoelectric crystal, we are having quartz, Rochley salt, etc. Rochley salt, etc. Okay, so first we'll see what is this here. So coming to the quartz, it has more stability, but the drawback for the quartz crystal is it gives a very small output. So whenever it is giving a very small output, obviously we need a signal conditioning circuit. Okay, obviously we need a signal conditioning circuit. Okay, it gives low output, so we use a charge amplifier. So we use a charge amplifier. Coming to the Rochley salt, your Rochley salt, it gives a high output, but the drawback is that, so I think you people might have studied about humidity measurement in your transducer in your colleges. Okay, in humidity measurements in nature we are having some salts. Okay, there are some materials or salts which are very sensitive to the humidity. So your Rochley salt is sensitive to humidity. So depending upon the humidity, it may change. Hence, depending upon the environmental conditions only, we have to select Rochley salt for our usage. But the advantage is it gives a very high output. Okay, it gives more output, but it is operated under some climatic conditions. Only. Okay, so these are some of the important points related to your piezoelectric crystals. So that's it. So this is the basic theory part of your piezoelectric crystals. Please make it fast. So don't make this concept piezoelectric crystal complicated. It's a very simple concept. Yeah. Now see here, just keep the slide reading formulae. We are having some formulae. I'm going to give 5 formulae so that we can solve any type of questions related to piezoelectric crystals. Okay. Please write down formulae. So please write down the first formula. The first formula is E is equal to GTP, that is equal to GTF by A, where E is equal to output voltage from crystal, T is equal to thickness of the crystal, and G is very important, voltage sensitivity constant, and the units are volt meter per Newton, Vm by N. The units are Vm by N, V for volts, M for meter, per N for newtons. Okay, F is equal to force applied, and A is equal to area of the crystal. So this is the first formula we are having. The second formula is Q is directly proportional to F. Q is equal to Kf, where Q is charge and K is charge sensitivity constant. Charge sensitivity constant. The third one, G is equal to K by epsilon. Already I have given the formula for G, voltage sensitivity constant, K is charge sensitivity constant, and epsilon is, as I said, that piezoelectric crystal is exactly similar to a capacitor, so epsilon is dielectric constant. So the fourth one, delta T is equal to capital E by Gy. What is delta T? Change in thickness. And E we know it is the output voltage of the crystal, G is voltage sensitivity constant, and Y is Young's modulus. And the last one is Young's modulus. Y is equal to stress by strain. Stress is equal to force per unit area. And please listen here carefully, it is very important. We are having the same formula, Young's modulus, for strain gauge and piezoelectric crystals also. In strain gauge, we represent Young's modulus is equal to stress by strain, where strain is delta L by L. Whereas coming to the piezoelectric crystal, the strain becomes delta T by T. This is the only difference. Delta T by T. That's it. These are the 5 formulas we are having. Please make it fast. So it's 6:40. So I'm covering the formulae. The first one is E is equal to GTP. Okay. The next one is Q is equal to KF. The third one we are having. Actually, yeah, fine. Yeah. So that's it. This is the theory part related to your piezoelectric crystal. That's it. Now please write down. Please write a question. We'll start from the basic questions. Write down. Start writing the first question. A 2.5 mm thick. A 2.5 mm. A 2.5 mm thickness. A 2.5 mm thickness quartz crystal has a voltage sensitivity of 0.055 Vm per N. 0.055 Vm per N is subjected to a pressure of 1.4 meganewton 1.4 meganewton per meter square. 1.4 meganewton per meter square. Full stop. If the permittivity of the crystal is 40.6 into 10 power minus 12 F by m, the permittivity of the crystal is 40.6 into 10 power minus 12 F by m. Calculate. The first one is output voltage, capital E, and the second one is charge sensitivity constant. These are the two questions asked. Please make use of your calculators. So initially I have started with the basic question. Okay. So voltage formula, we are having only one formula to calculate voltage, that is E is equal to GTP. See, please observe here carefully, the standard unit should be there. For voltage sensitivity constant, we should have a standard unit, nothing but voltmeter per Newton. Okay, make this point clear. So G is 0.055, thickness is 2.5 into 10 power minus 3 into pressure 1.4 into 10 power 6 to solve this one. So if you solve, you will be getting voltage as 192.5 volts. 192.5 volts. The second one, already I have given the formula, K is equal to epsilon G. K is equal to epsilon G. Epsilon is 40.6 into 10 power minus 12 into 0.055. 2.233 PC per N. Pico coulombs per Newton. Yeah, please take down the next question. A piezoelectric crystal measuring 6 mm into 6 mm into 1.5 mm. 6 mm into 6 mm into 1.8 mm. 1.8 mm is used to measure force. Stop. Its voltage sensitivity constant is 0.055 voltmeter per Newton. Full stop. Find the applied load. If the output voltage is 120 volts. Find the applied load if the applied voltage find the applied load if the output voltage is 120 volts. Okay, this is the question given. So in the question he is asking us to calculate the applied load. Applied load is nothing but force. Okay, so F force is equal to how much? We are having only one formula. Coming to the solution, we have E is equal to GTP. GTP is a force per unit area. So force is equal to EA by GT. E is 120 into area. This here 6 mm into 6 mm into 1.8 mm is nothing but length, breadth and thickness. So length into breadth, 6 into 6, 36. 36 into, please here don't make the mistake, millimeter into millimeter whole square. Millimeter means 10 power minus 3. 10 power minus 3 whole square is 10 power minus 6. Divided by G 0.055 into T 1.8 into 10 power minus 3. 43.63 newtons. The answer is this one. Chaliye, please take the next question. Please write down. The following data is related to barium titanate pickup. The following data is related to barium titanate pickup. Write down. The dimensions are 6 mm into 6 mm into 1.5 mm. This is a gate question, which is a somewhat old question. Okay. The dimensions are 6 mm into 6 mm into 1.5 mm. Comma. Force acting is 6 newtons. Comma. The charge sensitivity of the crystal is 150 pC per N. The charge sensitivity of the crystal is 150 pC per N. Comma. The permittivity is 12.5 into 10 power minus 9 F by M. The permittivity is 12.5 into 10 power minus 9 F by M, comma, modulus of elasticity is 12 into 10 power 6 Newton per meter square. First question, find strain. The first question is strain. Second question is charge. The third question is capacitance. Yeah. So this is also a direct question. So everything is there with you. You are having all the data. So from the data, just you calculate the strain. So to calculate the strain, we are having only one formula. Young's modulus is equal to stress by strain. Okay. I'm just framing the formula. Young's modulus is equal to stress by strain. Stress is there. Stress is force per unit area. Area is there, fine, not an issue. Strain is equal to stress by Young's modulus. Stress, force per unit area. Force is force per unit area into Y. So force is 6 divided by area, length into breadth, 6 into 6, 36 into 10 power minus 6 into Young's modulus, 12 into 10 power 6. So if you solve this, you will be getting the value of strain as 0.0139. 0.0139. Good, Gautam. Yeah, correct. Next भी find out करो. क्या है? Charge find out करना है. Charge का formula दिया था already. Please check the charge formula. Charge Q is equal to KF. Charge Q is equal to KF. K is 150 into pico. Pico means 10 power minus 12. So 10 power minus 12 into 6. So again you will be getting answer nearly 900 PC. Picocoulombs. Now capacitance. We know the capacitance formula C is equal to charge by voltage. Charge is 900 into 10 power minus 12 by the voltage is already given here. Not given? Better you find out E is equal to GTP. G is there. Voltage is there or not? Yeah, voltage is given. It's 3 volts. So finally the capacitance is 300 PF. Yeah, fine. So listen here. A small question was there. No need to write. Yeah, it is a gate question. Gate problem है ये. Gate question था ये. ठीक है. See here, please don't write, just listen the question. The question is like this. For signal conditioning of a piezoelectric crystal, we need options: charge amplifier, differential amplifier, integrator, and instrumentation amplifier. We know that for a piezoelectric crystal, the drawback is the issue with the charge. So in the option, okay, we are having an issue with the charge. So obviously we want, in order to amplify the charge, we need obviously a charge amplifier. Okay. Now listen here, one more question. I'm repeating the, don't write, just listen. A piezoelectric type crystal of 50 megapascal pressure sensor with a built-in electronics has a sensitivity of 100 millivolts per megapascal. Okay, if this sensor is subjected to a static pressure of, if this sensor is subjected to a static pressure of 10 megapascal, then its output will be, options, tell me the answer. Yes, correct. But here, in order to confuse you, the options are like this: 0 millivolts, 100 millivolts, 1000 millivolts, 1000 by 2 millivolts. So be careful. If you are talking about the piezoelectric crystal, obviously the input should be always a dynamic. If it is going to be static, whatever is the magnitude of pressure you are going to apply, obviously the output is always 0 volts. Make this point clear. Okay. Now go for the next question. Yeah, please write down. A quartz crystal, this is also gate question. A quartz crystal, write on the bracket, Young's modulus is equal to 9 into 10 power 10. Young's modulus Y is equal to 9 into 10 power 10 Newton per meter square. Newton per meter square with piezoelectric properties. With piezoelectric properties, has a diameter of 10 mm, has a diameter of 10 mm and thickness, and a thickness of 2 mm. Thickness of 2 mm. Full stop. If the voltage sensitivity constant, of this crystal is 4500 volts per micrometer. Full stop. Find the applied load if its voltage is 127.3 volts. 127.3 volts. I'm not giving the options for this question. This is also gate question. Is it clear? So applied load is nothing but how much force you are applying. You have to calculate the amount of force applied. Okay. So this is a question given. Okay. Now we have to solve this question. Okay. You people please don't solve. Just try to listen what I am going to do here. Okay. There is a small there is a small problem in this question from the given data. Okay. So we from the given data he is asking us to calculate the amount of force applied. Okay. So in order to calculate the force, we are having only one formula, that is output voltage E is equal to GTP. Okay. First, please see here, GTP. Nothing but GTP is nothing but force per unit area. From this, write down F is equal to EA by GT. Okay. So E is given. Area is nothing but. So I am framing the formula. Area is pi r square, nothing but pi d square by 4. Pi d square by 4. Okay. By G into T by G into T, correct? So delta T is there. Just 1 minute. So G is there, area is also there, E is equal to GTP, yeah, GT F by A, fine, F is equal to E by A, fine, E is already given, area is there, T, yeah, you can solve this one, thickness is also there, fine, good, not an issue. See here, if you are observing the question, in the place of G, we are having, if you observe the question, the units of G are not in the standard unit. The unit of G is not in the standard unit. So what we should do? We should convert the value of G into the standard unit. Now please see here. Now for that what I should do is that in the place of G, substitute G by Y in G. Why I am doing like this? Now you will understand. Now see here, in the G, just what is the value of G? 4500 volt per micrometer. This is divided by, Young's modulus units are 9 into 10 power 10 Newton per meter square. If you are doing like this, meter gets cancelled and this meter comes to numerator, then the units become, then it becomes volt, this meter comes to numerator, voltmeter per Newton. Can I say this as a standard unit? This is a standard unit. So in order to bring this voltage sensitivity constant to standard unit, I am doing a small calculation. Okay, so if you are calculating this, here 10 micro is there, so you will be getting 4500 into 10 power 6 by 9 into 10 power 10. This is my new G value, nothing but G by Y. So if you are calculating this, you will be getting 4500 into 10 power 6 is equal to divided by 9 into 10 power 10. So nearly I am getting 0.05. I am getting 0.05. Now you substitute this 0.05 here. So E is how much? 127.3 into pi into D. D is 10 into 10 power minus 3 whole square divided by G is this value 0.05 into T, 2 into 10 power minus 3 into 4. This is a way to solve this problem. Is it clear, guys? Yeah, see here, from the given data, he is asking us to calculate the value of force. Okay, so in order to calculate the value of force, we are having two formulae. One is Young's modulus is equal to stress by strain, or else E is equal to GTP, where P is equal to force per unit area. From this I am getting the formula as EA by GT. Okay, so E is given, A is nothing but pi r square, R is nothing but diameter by 2. So I can write it as pi d square by 4. So in the place of G, we can't substitute the value directly. The reason is that here the units are, what are the standard units? Voltmeter per Newton is the standard unit. So in order to bring that standard unit, what I am going to do is that I am going to divide G by Y. 4500 divided by this. Why I am doing like this is, you just take the units volt per micrometer divided by this Newton per meter square. Meter gets cancelled. I will be getting answer as voltmeter per Newton into 10 power 6. This value I am getting. So voltmeter per Newton is the standard unit. So because of that I have done like this. So if you solve this one, you will be getting the answer as 0.05. Now you substitute in the place of G this 0.05. Don't substitute the value of G directly. Then if you are substituting that, you will be getting a wrong answer. Fine. So now answer is nearly 99.9. So many questions are there. Some more two to three questions are there, which are also related to your direct questions. Only thing is that you should know the formula. Once if you know the formula, then only you can solve the problem. Any type of problem, anything. Okay, that's it. How to remember? Very good question, because this is very important. It will be useful for the remaining students also. See here, suppose you are doing, you just take my subject itself, transducers. Okay, so what you should do is that normally you should maintain a diary. every student should maintain a diary. Okay, it may be of 200 or 300 pages. At least you have to maintain 200 to 300 pages of diary. Okay, so now first you take the transducer part. Okay, now I think in the last session and today's session, totally I have taught nearly some 14 hours of class. Okay, in the 14 hours of class, in the first session I have taught the basics of the transducers. So now in the diary, first you keep the main heading as transducers, and then now you write down basics. So in the basics, now you started in the first formula. The first formula comes is percentage of accuracy is equal to measured value by true value into 100%. This is first formula. The second formula is percentage of accuracy is equal to measured value by FSD into 100%. And then error, percentage of error is equal to, like this, you first complete all the formulas whichever are there in the first topic, basics of transducer. So maximum 10 formulas will be there, maximum to maximum in the first topic. Once it is done, then go for the second topic. Second topic I think we have done with the potentiometer, I think so, I'm not sure exactly. Suppose let it be potentiometer. In the potentiometer we are having only one formula. V naught by Va is equal to di by dt is equal to Ri by Rt, that's it. Gone, completed. Next go for inductive transducer. In inductive I have given 3 or 4 formulae. Write down those formulae. Okay, in this way you cover all the formulas whichever we have taught. Suppose if after the completion of my entire transducer, process control and optics, maximum I will be giving the notes of nearly some 200 to 300 at least one book I am going to explain. I mean one book of data I am going to give. In that one book of data, you have to frame the formulae such that maximum within 5 to 7 pages the entire transducer, process control and optics formula should be incorporated like this. Once it is done, then go for controls. In controls, I think controls will be, if the faculty teaches you, then normally the control system notes will be nearly some 150 to 200 pages. In that 150 to 200 pages, again you frame the formulas such that by seeing the formula you should understand the logic. You just frame the formula according to you, not according to me or according to your friend. You just frame the formula according to you. So maximum try to write the formula or the logics whatever you understand within 5 pages. Single page. Both side means 10 pages you can consider. So maximum 10 pages. Completed. Done. Then go for digital. Again one more 5 pages. Like this every subject you can complete within 5 pages. So total you have how many subjects? 10 subjects. So 10 into 10, 100 pages. Sufficient. Okay, getting the point? So while going for the exam or while preparing for the test, you just go through this formulae. Suppose if you are studying this transducer, suppose the first topic is basics. If you close your eyes, then you should remember all these formulas. The formula and related to the formula, what problems I have taught, everything you should remember. In that manner you should study. Then only it will be possible. That's it. Other than this, there is no other logic. Even maths also you should have to do like this only. Is it clear? What is the instrumentation as point of? देखो instrumentation point of interview मतलब देखो it varies from company to company. Most probably they mainly concentrate on the transducer and process control. Process control पे बहुत ज़्यादा डेप्थ में जा सकते हैं. Like what is a controller? What is the necessity of controller? Why you are using a PI controller? What is the on-off controller? What is the advantage of on-off controller? What is the drawback of on-off controller? What are the advantages of derivative controller? Why the derivative controller is an anticipatory controller? What is the drawback of derivative controller? Why it should not be used alone? What is the use of PI controller? If you are using a PID controller, which control is going to be activated first? Or all the controls are going to be work at a time or simultaneously or one after the another? In this way, they can ask any type of questions. The thing is that you just prepare for a gate exam. If by God grace, if you are going to get a very good rank, then for the interview also, one more time you revise all the topics and then only you have to go for the interview.